Hey guys, welcome back to my YouTube channel. The topic for today is Pythagoras theorem in three-dimensional shapes. Pythagoras theorem in three-dimensional shapes is what we are going to learn today. Okay. All right. Now, I have seen from my experience that people are really good with using c square equals a square plus b square formula when it comes to Pythagoras theorem. But when it comes to shapes like this one here, which is a three-dimensional shape, they get a little bit confused. Okay. And that's what my purpose today is, to make that confusion get that confusion out of your mind. Okay, so the simple thing which you need to know when you use Pythagoras theorem in a three-dimensional shape like this, it has to be used twice. That's the simple thing. Okay, if you remember that, then you should not hopefully struggle with using Pythagoras in three-dimensional shapes. Now, what is the sort of question you can get in the exam? In the exam, you will get a diagram like this, and then they may ask you to find out the length of the longest rod longest rod you can fit in that rectangular prism. Okay, as you can see this rod here, that's the length of the longest rod which you can fit in that rectangular prism. Okay, so let's try to learn how to do that. So, first thing you are going to consider is this bottom triangle, this green one. So, this green triangle here, that's what you're going to consider first. As you can see, that green triangle there is a right angle triangle. Why is it a right angle triangle? Because if you look at this dimension here, sorry, my bad, I have been using eraser, so I just accidentally erased it. So we have to quickly reconstruct that. Just give me a second. Bear with me. Okay, all right. Now, so that this green triangle here, we are getting that triangle from this rectangle in the rectangular prism. Okay, now any rectangle, every single angle in a rectangle is always a 90-degree angle. All right, so if we were to use Pythagoras in this triangle here, let's just assume this side here is 12 meters, this one here is given to be 9 meters, and then this one here, this length here, is given to be 8 meters. 8 meters. Okay, all right, so now when we use Pythagoras in this triangle, let me draw that triangle out for you. This one, the green triangle. Let me get the green pen so that we know which triangle we are dealing with. So actually, I just realized in here it's not even green, it's blue. Okay, so let me see if I can get the blue pen out instead. So let me erase this green one and get a blue one ready to know which triangle we are dealing with. So we're dealing with the blue triangle in the diagram. Okay, so blue triangle is simply 90-degree angle, 90-degree angle, and this length here is 12 meters. As this one here is 9, that means this length is also 9. Why? Because of the opposite sides of a rectangle are always same. So if this is 9, this one's 9, this is also 9. That's how this side comes out to be 9 as well. So that side comes out to be 9 as well. Okay, all right, so we can now use Pythagoras theorem for the blue triangle. C square equals a square plus b square. As you know from my previous videos, any of the sides out of 9 and 12 can be an a and b. So simply substitute 9 square plus 12 square for a square and b square, and your c square becomes, your c square then becomes I need a little bit more space. So c square is going to become 9 square plus 12 square should give you 81 plus 144 is going to be 200, 200 and 225. Sorry, my pens are playing up on me a little bit today, so just bear with me please. 225. Okay, I don't know what's wrong with my pen. So basically it should be more clear now this time. 225. Okay, all right. So c squared now becomes 225. As we know that we do not need c. We are not after c. We are not after c square. I mean, we are after c. Okay, so we need to square root that. If you need more information on how to square root, watch my very first video, which is the topic is Pythagoras theorem. So to get rid of this square, we're going to square root, and square root of 225 is 15. So that means this length here, that one there, comes out to be 15. So I'm just going to fit it in here so that you can see properly. Now we get it as 15 meters, right? Now, if you imagine when this one comes out to be 15, we know in another property of so the same property, I mean, of a rectangle, if we consider this rectangle, if this side is 8, then this also has to be an 8, right? Because again, opposite sides of a rectangle are equal to each other. So that's how, if this is an 8, then this one also has to be an 8, right? Okay, all right. So, and another property of the rectangle is that this angle here is also going to be 90 degrees angle, right? All right, let me get my yellow pen out now, because what we need to do is I will quickly rub all this mess for you guys first so that you are going to know what I'm doing. But I might get um my dimensions back up there. So this one here, we've considered it to be 12 meters. That one was 12. And then this one here was 9. Actually, I'm not going to need that 9 anymore, so I might not consider it. I am going to need my 15, which I just found out. So this side here was my 15, right? And then that one was an 8, and this is also an 8. All right, so let's get our yellow triangle up. So yellow one, I'm going to solve my yellow one now. It doesn't look, not going to look like a right angle triangle, so we have to reconstruct it. All right, so this is my yellow triangle. Okay, so as you can see, I have an 8, I have a 15, so I can put that 8 here, I can put that 15 here. So both of those are in meters, 8 meters and 15 meters, right? All the dimensions are in meters. So we are going to reuse our Pythagoras theorem. We're going to reuse our Pythagoras theorem to find out the length of the longest rod which we can fit in there, the length of the longest rod, which is my red dimension, which is this bit here. Okay, because that's what the purpose of the whole problem is, finding out the length of this longest diagonal or longest rod. Okay, so it is now going to become a piece of cake for you guys again, because what we need to do is we need to use our magic trick again, which is our Pythagoras theorem. C square equals a square plus b square. And this time my a's can be an 8 and my b can be 15. So 8 squared plus 15 squared. Okay. Now 8 squared plus 15 squared, 64 plus 225 I am pretty sure it is 289. So c square comes out to be 289 this time. Again, to get rid of this square, because we are after c, not c square, we will be square rooting 289. All right, so square rooting 289 simply gives us 17 meters. So c comes out to be 17 meters. All right, that's the length of this red side. That is the length of the longest rod which we can fit in. So this one here comes out to be 17 meters. Okay, so if it is a word problem, I strongly advise you to write down therefore. So these three dots, they are called therefore. Therefore, the length of the longest rod, or a diagonal, sorry, in a rectangular prism, or in the above. I would say in the above, because it doesn't have to be any rectangular prism. You need to have these particular dimensions for it to be 17 meters, right? So the length of the longest rod or diagonal in the above rectangular prism is 17 meters. Okay, easy. So that's the beauty of using Pythagoras twice in a three-dimensional shape. Okay, I hope you liked it. I hope you understood the concept. This concept is widely used in 11 general maths, but it actually starts from grade 10 onwards. And so, if you understand the concept right, you can tackle any sort of Pythagoras theorem in 3D shapes. So any sort of 3D shapes. Thank you so much for watching it. If you've got any feedback, please don't forget to share it in the comment section. Also, if you need any particular topic, if you are struggling with any particular topic, you just put that in the comment section, and I'll try my best to upload videos on that topic for you guys. Thank you so much, guys. Don't forget to share it with your family and friends, and thank you for your support.